does. So thanks everyone for joining the second session in this eco-nomics round of planning workshops. So to start off with, so first of all, I want to acknowledge the traditional owners of the lands on which we meet and the lands which we're going to talk about as well, and pay our respects to elders, past, present and emerging. This collection of products that we want to talk about today is really some background and context as to what we're going to use as a basis for building the economics world. So we've been working in the reef space for the last several years, but the last 4 years in particular, developing a series of different products to support. Collectively, it's about $60 million a year worth of management practice projects get captured through these different products. So I just want to run through those, and it'll give you some context and background, and it'll help make sense of the future discussions we're going to have about some more detailed aspects of how these things work. So let me share a screen, and I'll try and get a presentation going. So just a couple of slides to introduce things. So for those of you who are here on Monday, so this concept of the economics platform, there's 4 key elements to it. So it's economics plan, and that's what we're going to be working on largely over these series of meetings. So that's a sub-catchment level, kind of lumped model for coming up with investment portfolios. The next level down is economics project. So it's a farm scale modelling or paddock scale modelling for capturing individual projects and predicting the outcomes sort of more accurately. We've got economics reports, so about being able to publicly communicate all the awesome work you've done or what you're going to do, and then those things related through a marketplace. So being able to capture these products in a way that can adequately support different markets. So what I want to do today is talk about each of those elements within the context of products that we've built in the past. So in the economics plan area, so there's 2 products really that relate here: Refinomics and a Catchment investment decision support system for Southeast Queensland. Economics project, so project level capture, is P2R Projector, and with us here is Adam Northey. He's from Queensland Department of Ag and Fisheries, and he has kind of been the primary champion developing this product along with us, which has been great. Economics reports, some examples of some public reporting dashboards, and economics market, so a product that we're in the process of developing now, which is to support issuance of reef credits in the Great Barrier Reef catchments. So let's get out of that, and let me just jump into each of these products. I'll whiz through. If you've got a burning desire, you can ask a question as we go. That's fine. It'll just be captured in the video, and then at the end of the session, we'll stop the video and you can ask some coolier questions. So let's start off with that plan level. So this Refinomics application is building on sort of 10 or more years of catchment and paddock scale modelling in the Great Barrier Reef area, and the intention here is to be able to bring that modelling together in a way that can support NRM investors come up with portfolios of investment that is targeted to targets or budgets or areas of high priority. So let me just jump through an example, create a scenario, and you'll get a sense of how it works. So let's make a new scenario in here. Let's call it demo will do. And in this case, so we've got 3 alternate modes we can run this thing in. We can try and meet the targets. So let's just do that. So we can meet the catchment targets. the region targets. So there's 6 regions in the Great Barrier Reef, and each of those have individual targets. And there's overall Great Barrier Reef targets. And depending on which one or combination you choose, the different result potentially. So for example, if I go for just GBR targets, it's just going to do the cheapest work anywhere to achieve the net reduction in dissolved inorganic nitrogen or fine sediment to achieve those targets, which might mean some catchments will get lots of work done and some catchments won't. So if we have catchments and GBR targets, we're going to try and achieve the set target within each catchment, but ultimately we need to reach the GBR. So if some catchments have insufficient potential work available, you'll do more work in other catchments, effectively overclock the work you do in some catchments to try and meet this combination. Anyway, pretty much detail, I'm sure. Or we can perform all actions, so we just create our own portfolio and say what would that cost and what would be the benefit of doing those actions. Or we can shoot for a budget. So if I've got $500,000 to spend, what should I do and where should I do it? And then we have this concept of adoption. So it's not just about what's the water quality benefit, it's what's the likely level of uptake of each of these different actions that we might consider. So for this this first case, let's just assume the traditional way that we'd model this stuff, we just assume that we're going to have 100% of farmers turn up and they'll adopt the activity immediately. We can choose a location to do this work. So let's just leave it the default. We're going to do it in all 47 of our subcatchments. Now we come up with filter our set of potential actions to consider in this scenario. So we have the notion of libraries of actions. So we've got a default master library where we curate all the data, but then at a local level or a project or organization level, you can have duplicates of that and variations of that and edit it, have your own instances of the different actions. So we've got an actions library. It's called V27. You see we've been going at this for some time to get up to version 27. And within that, this list over here are all the different actions that we've got represented and quantified for Great Barrier Reef. So around about 100 of them. So this one here, we're in dryland cropping. We're going from soil management practice improvement from moderate to low risk. And we're calling that a B to A being the lowest risk, moderate being the B. So there's a bunch of practices that have been modelled that move you from that transition, and we've come up with an efficacy or an effectiveness load reduction that you achieve by doing that. So similarly, we've got that across many things. So we might not want to consider all of these things in our portfolio. So we consider, let's shoot for the dissolved inorganic nitrogen target. So we'll turn off everything that's primarily a fine sediment focusing thing. So that gives us a nice small list. Sewage treatment plant, let's stick out of the urban space, so I can turn that off here. And let's stick with things that are probably more well known or well represented in the modelling. So the constructed wetlands, turn that off, and I'll turn off bioreactors. And this is probably a bit controversial about, well, what would it take if you converted sugarcane land to grazing land? Let's turn that off. So effectively what we've just got here is sugarcane and banana industry, mostly nutrient management activities, which is largely where DIN reduction activities are targeted. Anyway, so there's plenty of other ways we can filter, so that by the pollutant source, by the way that we're representing the effectiveness, how fast this activity will respond. So each of these different effectiveness has a temporal response. Linear effectively means we don't know what the response is, so we just assume it's going to be over a 15-year time span will be linear. Fast, we've got a relatively rapid response and then it'll slow down. Slow might be a slow initial response that will then increase. Something like putting up a fence, waiting for the trees to grow. And then ultimately you'll get the sediment reduction, but it'll take some time to get there. And instant is when you're dumping rocks or pouring concrete. And we've got underlying confidence in each of those predictions. And so we could filter these activities by only having high confidence activities and also filter them by levels of adoption. Okay, so we've got our filtered subset of actions to consider. Now we can prioritize those. So we've got about 16 different ways to prioritize here and combine. So we've got nitrogens. I'll turn off fine sediment. We don't care about that. So we can prioritize on the target constituent. We can prioritize on the response time. And we want to achieve this over 15 years versus 5 years. So the 5 years, that'll prioritize towards the more expensive concrete and rocks, and the 15 years will be the typically less expensive revegetation, but longer response time type options. We've got some industry-based ways to prioritize. So this is about kind of determining economies of scale. So you do more work in focus catchments, the target most polluting industries, target most polluting catchments, target adoption likelihood for that industry. And then what we're calling here are co-benefits. So these are the things that we have effectively a qualitative representation for every one of those actions.
Nick, can I ask a question? On this one, you're only picking one option out of those, but on the last sheet, you had 4 options all ticked. How does that work?
Hang on. If
you just go back
here.
Yeah, back. So how can you have your all of those ticked? Don't you have to you say response type? Don't you have to just choose one response type?
So every one of these actions is represented in, or this one is yield based. So if I turn off the efficacy based ones, these are the modelling mechanism is a yield base, so it's a kilogram per hectare. Efficacy-based ones are a proportional reduction, like you might do for a traditional riparian revegetation, you know, a 20% reduction.
No, I get that. I'm just wondering how do you have to select each? I'm just wondering how you can have them all ticked at once.
Well, all ticked at once means include every one of our 100 options, 100 different actions, we call them. And by unselecting them, it just means remove those from the list. So I've removed from the list things that are targeting fine sediment. And I've removed from the list things that have a fast response.
I see. Yep.
Do you know what I mean?
Got it.
Yeah. In fact, that's that really good point about usability. So I reckon this is how the world should work. It should be pre-ticked and then you untick. Traditionally, what you'll see, and we probably should swap this around, they should be all unticked to start with, and as you expected, you tick them to remove them from the list. Anyway, so you get what we're going. All we're doing there is filtering the list, and then in this prioritization screen, it's about of those 100 activities. So let's go down to this list below. Of those 100 activities, we now have those activities represented in each of 47 subcatchments. So, well, not all activities occur everywhere. We've got about 4,000 actions, and this is the list and listed down at the catchment level. So this is the first thing it says that you should do is work on grazing management in forested areas, transforming them to C grade management to B grade management in the Burnett Mary region, in the Mary catchment. And then once you've exhausted that, you should go and work on grazing forested management C to B in the Fitzroy region, in the Fitzroy catchment, in the lower Fitzroy subcatchment. And by altering this sets of priorities, I can resort that list, depends on how sensitive those activities are. And what have we got here? We've bumped up some STP related things. I bumped to the top with that set of priorities. So, back to what I was. Oh, it's probably a short time frame. And hang on, I'm going to go back, and I've got everything selected, sorry, when I was showing you, Ian. So I'm going to go back and turn those things off. Get back to where we were, configure actions, apply that. So we're back to just the DIN related things. I'm going to save it and I'll run it. While that's running, I'll jump through and just show you a couple of pre-run examples that Tom and I were playing around with this morning. So I've run something shooting for fine sediment, hitting our fine sediment reduction targets, assuming 100% immediate adoption. So this is our total reduction, 770 odd kilotons for about $12 billion. The orange line here represents our overall fine sediment reduction through time. Cost through time, marginal cost abatement curve. So every one of these little dots is a different action being conducted across one of those catchments. The green represents the nitrogen. So in this case, we're targeting fine sediment. And then ultimately, we've got a table at the bottom that lists out every one of those actions kind of in order, what it costs, what the area that we're going to apply it, and what the overall improvement is going to be. So we've got that at the catchment level, drilled down to the same thing at a sub-catchment level. This is showing our response here in relation to hitting the target, and so on and so forth. I won't delve into that. Then you get the concept. What we also have is the representation of the co-benefits. So it's the relative size of these bars. So the local economic co-benefit, environmental, social, and the other co-benefits must be so small that they don't even fit in that bar. Okay, so another little point I want to show here. So you see look at the overall price, 12 billion, and the shape of this curve. So we're assuming everyone's going to turn up, and the slope of this curve is just about the response time of those activities, how long it takes for them to achieve the watercolour reduction. If I run the same scenario and I turn on the likelihood of adoption, click to the next tab here. Here's the slope. So it takes a hell of a long time to get there because not everyone shows up on the first day, but you also exhaust the cheaper things quite quickly and you have to move into more and more expensive activities to achieve the same outcome. So if you look down, we've gone from 12 billion to 28 billion by trying to be a bit more realistic in the likely adoption level. So that's a neat story. What else was I going to show? And so that was running at, have a look at that. So 12 billion immediate adoption going for catchment targets. And then I break here. Don't worry. I was running that one in the background. Don't need to worry about it. So another story was about comparing the different targets. We won't have time to get there, but I just wanted to talk about what those actions are. So we have these things called action libraries. So in this case, I've got 4 different action libraries, and I'll jump into one of those. And this is where we capture all the details that represent each of those actions. So this is we've got 100 different actions in this line. I've got those cropping ones I opened up to just to step through. So we can describe what it is. The principal page is about the attributes, so it's the type of action, the type of effectiveness. So yield is a kilograms or tons per hectare, depending on the constituent. We've got a pollutant source, so it's the land use source, if you like, that we're targeting. So we need to be able to work out how much of this available thing we can do. So we populate it with, define the land use areas, and then we've kind of got a subtype as well. So management, in this case, we've got management practice B moving to management practice A. And some things we don't have subtypes for, but it's where that resolution of land use exists, we can represent. So we're representing how fast that response happens. There's very precise cost estimate been generated here. We don't need that many decimal places. And how much of the available area should we apply it to by default? So, for example, we'll run those defaults down to maybe 5 or 10% when we're thinking about linear features like riparian management, because there's many kilometres of it. So these overall figures are our defaults, but then we've got at the subcatchment level, we can have subcatchment specific values around efficacy, and that's what we have here. So we've got underlying catchment models that represent what those likely loads would be. So it's not the generic number applied across the whole GPR. There's subcatchment specific effectiveness values and cost values as well, if you have that level of detail. So we've got that. We've got a representation of confidence. So it's a kind of heuristic measure to give you an overall confidence rating. The adoption approach is using the CSIRO's ADOPT methodology, which is a 20-odd question questionnaire, and some interesting maths behind it that comes up with an overall likelihood of peak adoption and a time to achieve that adoption, which you can overwrite with sort of manual numbers if we have those. And our co-benefits here are a simple Likert scale approach with effectively an averaging process to give overall co-benefit measures. So being able to represent these things that we don't have a quantitative number for, we can represent them qualitative. So now, quick run through. So that's effectively what Reefonomics is. Ultimately, to produce portfolios of activities or actions, represent what the cost and the likely benefit might be, and underlying that are kind of libraries of the detail that's drawn from the available data and modelling, and managed by data custodians, so that we've got some confidence in how that works. Now, so that relates to largely this first part of eco-nomics, our economics plan. We want it to operate at that same level, but we want it to be able to be generalised outside the reef. So it's not just in nitrogen and fine sediment, and it's got to be a bit more flexible about using other available kind of data sources. So let's jump on to something else that operates at this scale, so that we've worked on in Southeast Queensland. It's called the Catchment Investment Decision Support System. So this is done with SEQ Water. So SEQ Water spend about $10 million a year on source water protection. So it's about doing stuff in catchments, and they've got about, well, they've got 30 different catchments, 30 different water treatment plants or reservoirs that they want to do work upstream from. So $10 million a year doesn't go very far. So if I zoom out here, you'll see the domain that they work in is everything outside that mask. I'm showing you a little scenario here in the Logan catchment, and before it's quite red, after it's still pretty red, so it's pink. So in Southeast Queensland, and this is a kind of water supply world, they talk about things in terms of risk and using that kind of risk framework for things. So it's about presenting an investment prioritisation approach that works in that risk world. So in this case, we've gone from a level 5 risk for this catchment to a level 4 risk afterwards. And those risks are all specific to each catchment. There's a risk profile for every water treatment plant. Some of them have a greater capacity for dealing with the key things that they're trying to protect in the catchment is about total suspended sediment and microbial threats, because they're the things that are expensive for managing the water treatments around. So So this investment prioritisation process is about trying to get the greatest reduction in risk per dollar, and where that risk is based on suspended sediment and microbial. And the threatening processes that we target with these investments is gully, point source, channel sources, landslides, unsealed road and hill slope erosion sources for PSS. And for microbial, we're dealing with recreational sources, stormwater sources, sewage treatment plants, broad-scale livestock, on-site systems, so these are like unsewered septic systems in rural areas, and intensive livestock like feedlots. So for this collective region, these are our top 4 things: 18 kilometres of riparian fencing, riparian re-veg fencing and off-stream watering, plus just riparian re-veg for an additional 20 kilometres. We can go down to a finer detail. So these spatial units, which we call planning units, about 50 square k's or less. And then each one of those has got a sub-level of activity. So this interface that I'm showing you is designed to be able to be shared within the organisation. So it's about the source water protection team be able to communicate with the pumps and pipes guys about what's going on in this investment program. And then behind the scenes, the source water protection team. Actually, let me jump to. Yeah, this is a production version of the same thing. Let's jump in here. So the next step behind here is the scenarios that the source water protection team is running. So you can see that they run 780 different scenarios, probably in the last 12 months or so, considering the different combinations and permutations of how they might invest and how you might prioritise. And each one of those scenarios has got to set up something like this. So we've got each one of those catchments has got a series of input data that drive those things. And there's effectively a threat threshold. So it's kind of the risk profile that relates for that catchment. Different interventions that they could consider. So you might have a scenario with hard engineering versus soft engineering. So channel erosion related activities, broad scale livestock related activities. So there's about 60 different things they consider, and every one of these things has got a relative effectiveness on each of those threatening processes, and there's a price value that goes along with those things. And we can also set up a prioritized kind of weighting, if you like, hazard weighting across these different things. So I might want a scenario that just focuses on sediment or just focuses on bacteria. So in this case, we're not focused on viruses. And this thing, unlike the Refinomics, which is largely that's a hybridized version of a marginal cost abatement prioritization approach. This is a simulated annealing optimization approach to coming up with that considered investment. And I'll show you one final screen here from the CIDSS. We call this the review and refine screen. So the idea here is computer says, here's the optimal investment portfolio, and then humans say, well, that's not going to work because I've got another investment opportunity over here or a co-investment. So we call this kind of the pragmatization screen. So, okay, so we start off with this level and click down to the sub-levels. I can get to the detail then of what do we propose to do in this sub-catchment? Well, we propose to do some re-veg and fencing and about this amount of it. And so the idea here is we can edit those things and overwrite them and say, okay, we use the optimal solution as actually the base case from which humans get to override those things and come up with a pragmatic solution that's probably going to work. And to aid that process, so we have just context layers. So that was a channel erosion layer, location of gully, landslip sites, our intensive grazing layers. It gets all a bit overwhelming when you turn all these things on at once, but it allows you to give you context about what might be possible in these different catchments. Okay, so that's kind of what we're building on at this economics plan stage. Let me quickly then jump to right here. P2R projector. So you've got that plan stage. We're going to do some investment. How do you capture those projects and work out what to do and how to optimize? Well, not really optimize. How to work with the land manager to get the best outcome you can. So that we have this thing called P2R Projector. And I was saying before, so Adam Norley's been the champion for this product. It's really great, I have to say. So this is really building on a whole bunch of paddock modelling from the state government, and to present it in an interface that project brokers can use. So I've got a collection of projects. I'll call it my first collection here. Let's zoom out. I'll show you the domain. So we're working across this broad domain. My project collection of where those little dots are spread all over the place. So it's just a little demo. And I can select all of those things. I've got 18 projects in here. There's a total nitrogen, fine sediment, and pesticide savings for that collection of activities. Let's turn them all off again and go and find back. What was I looking at before was going to be my first project, was the one I was playing with. This one, turn that on, we go and zoom to it on the map. That's it there. Okay, so just got one project selected here. My first project, let's go and see how it works. So we've got, clicked on the pencil there here. This is effectively the survey. I can allocate which funding source it comes from. So that's excellent for post-processing and working out who funded what works. And then ultimately we've got a questionnaire. So this questionnaire is about agricultural management practice related to, and this project's a sugarcane project. So it's about different management practices. This is about soil management, this series of questions. There's a series of questions here about nutrient management practices that are relevant for that industry, so on and so forth. And you go through that process, and we haven't changed anything, so it's not going to rerun. So we've answered that survey, and that's our project on the ground. I can add another block to that farm. Okay, we're going to extend that work a bit more, and now it's going to recalculate. It'll apply all those survey questions for that block. It's going to intersect that block with an underlying soils layer and a rainfall layer. So, for example, the sugarcane, we're really looking at around about 6 million simulations of APSIM for every combination of agricultural management practice and soil type, to come up and run for about 30 odd years, then to come up with an annual average nitrogen, sediment, pesticide loss. And we do that with our before and after survey questions and work out the difference. So in a nutshell, that is P2R Projector, and it works across the sugarcane industry, banana industry, grain and grazing industries, and all of them are a little bit, they're a bit different, but what's neat about this is effectively the grazing is a generalized solution, can be applied anywhere. So it uses an external service supplied by the Queensland government, which runs the USLE. It's effectively, we come up with a series of questions that ultimately estimates a change in cover, end of dry season cover factor, and it runs the USLE, so that can be applied elsewhere. And to support the banana and grain industries, they use a how leaky model, which is an agricultural practice water quality model, and that through support from the Queensland Water Modelling Network and now extended by DAF, thanks again to Adam, to generalise that solution. So we've got a digital API service to be able to call those industries, and there's about 30 additional crops that you might, or any kind of agricultural industries, a water quality model that can be set up and calibrated for anywhere in the country. So even though we've got some really great specific implementation across the reef, the technology used to do that is now generalised and can be applied essentially anywhere you like. So let's jump on to the next part of eco-nomics, the economics report. So that's all great. We've planned our projects, we've captured the projects, and we've got to tell the world about them. So I don't want to bang on about this too much, other than the impact reporting is a super critical thing in our world, and I think we've undersold ourselves terribly. In NRM, we do an amazing job and don't tell anyone about it. So this is the interactive reef report card that we produced across all that reef level investment, that to be able to allow people to, demonstrate what they've done. See, doesn't sound so good, does it? Say it that way. To be able to have graphics, get to the underlying data, and link to underlying information that supports this as well. So it's a progressive disclosure approach to presenting stuff. Similarly, so this is not a Queensland well, so here's one for your part of the world, Ian. So Port Phillip and Western Port, we've got a report card going on down there. And it's a reasonably complicated world as well. So this is kind of annually updated representation across, rivers, wetlands and estuaries across that broader region, and drilling down to these different details. That's probably enough. And I'm going to jump to the final thing that I wanted to cover, so that we've still got some time for questions, is Reef Credits Projector. So I'll show you some of the high fidelity mock-ups. So we're still in development. This won't be released for another month or so. But the idea is the Reef Credit Scheme in Queensland, relatively new, and the method, effectively what you've seen in that Paddock to Reef projector for quantifying the likely reductions in nitrogen, is the basis for applying for reef credit. So a project broker will work with a landholder, get them to sign up to do management practice change, and then there's a process then of annual review and external auditing to make sure that everyone's doing what they said they would do. And the basis of that, the state governments, well, they're purchasing the initial $10 million worth of reef credits, but there has also been some external sales now in reef credits as well, because it's effectively like a carbon credit scheme, but a scheme that has lots of controls around it, if that makes sense, and external ordering to make sure that people are getting what they say they will. So just step through this to give you a little flavour of how it works and how that crediting system works. We have projects in here, so this is just mocked up information. We create a new project, give it some details. We link all the associated documentation around that. So you have to make, anyways, background administrative documentation. There's a baseline process under the reef credit, so you've got to be able to represent what's gone on this land holding for the previous 7 years. And so that's the baseline from which we're assessing a change. So we've got a mechanism for capturing each of those 7 years and across different industries. Let's just jump through these example questionnaires. Jump further. We're getting onto the second year, and we'll so on and so on until we get to the end of our 7-year baseline. We get an overall record of load exported to the reef from that farm over those 7 years, and that's effectively our baseline number that we're going to record a change from. Then we capture for each monitoring period. Again, we go back, assess the farm and the practices of the farmer for that year, capture the difference between those two things, and then ultimately represent, and then that goes to a third-party auditor to make sure that everything is true and correct, and that difference effectively forms the basis of a reef credit that then can be traded as a saving of, in this case, nitrogen each year. And that's probably enough. I'm going to run out of time for questions. So this session I'm recording, and I'll stick it on this eco-nomics.net.au. I've got a tutorials area, so each of those sessions I'll stick there so that whoever, if you can't attend, you can see those. Go and have a look at those videos at your leisure. So let me get back to that screen, and I'll turn the video off, and we can